So this time what I want to show you is how we go about positioning our wall plates and then marking them out so we're ready to construct our walls. So in this example I'm going to use a slab, but it could as easily be a bearers and joist floor that we're working on. So the first thing we need to do is we need to make sure, we need to mark out where our walls are going to go on our slab. Some people may construct their walls straight off the plan, and it works if you've got a bit of experience in it. But the foolproof way of doing it is to actually mark it all out on the actual job first, and then work from that. And that way you shouldn't stuff anything up. If you work off the plan, quite often the plans differ to what's on the actual job site, so there are always some opportunities for mistakes. So best thing to do is actually flick it out or mark it out on the job site. So the first thing I'd do, especially with a slab that I had nothing to do with constructing, is run my tape over it and just check that it's actually the right dimensions. You may find that the concreters have made a few mistakes, and you may need to compensate for those mistakes. So if, for example, if their slab is a little bit undersized, you may have to actually position the wall plates so they overhang the edge of the slab a little bit. Generally anything more than 20 mil is not acceptable, but if it's only 5-10 mil then you can get away with it. Also they may have made the slab too big, or it may have bowed under the weight of the concrete, and you may just have to center the wall frames up on the slab. So always a good idea to run the tape over it first and make sure that it's close to the mark. The next thing I would do then is you need to establish the longest straight line, or the longest wall you can find, which is generally one of the external ones, and get a nice long straight line down that wall. Once you've got that, you can then flick out a line at 90 degrees to it. Now, once again, in the perfect world, the slab will be square, but you can't always trust it. So I always use Pythagoras or a 3-4-5 triangle to establish square on the first two lines. And once I've got the first two lines done, I can then just measure off parallel to get the rest of my walls. So this is a pretty simple plan for this video. As you can see, if I got the position of this line and I had this at 90 degrees, then all I have to do is measure parallel measurements down, and then I could flick that line, measure my wall width, flick that line, measure parallel down to here, and I'd try where I can to use overall measurements. So measure from here down to this wall, just to make sure everything was working as far as the plans go. And same, all these measurements coming off this line to here. And you can see that there's my plan. So I can use the measurements off my plan to establish all that. The next thing to do is then we need to lay out the position of our wall plates. So generally we consider 6 meters to be the longest length of timber we can get. So we need to think where we're going to join our wall plates. So intersections are always good. It's a good strong place to join our plates. But we definitely want to avoid windows, and we definitely want to avoid doorways. So we need to think, let's see, that's 5.2, so it's under 6, so we could go from there to there. We then need to get in between the door and the window there, or we could go between these two windows with a plate. Either one of them would work, because that measurement's going to be, definitely be under 6. Once again, this way, we could join on that intersection there. We could join that intersection, and once again on this side, we're going to have 6 one length to there, and somewhere in here we could join on that intersection. This way, we're going to have to join in the middle of the wall. So you just need to plan where your plate's going to go. So we go back to our building, and we can put a plate there. So it's going to join at that wall intersection. Put a plate there, so that should join between the door and one of the windows. and obviously it's going to run across to the end then. Similar at the back. On this side, that one doesn't particularly matter, it can join anywhere. That one's going to join at that intersection. This one here, I've just done the same as what I've done there, so a bit of repetition. Could have joined it there if I wished. And those two are just full lengths and a full length in between. So we actually lay them out on the job site. Make sure they're cut so they fit in nice and tight, and they're all on the lines that are on the slab. Then we can go around, and from our timber, we can actually mark out our intersections. So I've gone around now, and all our intersections have been marked out. I'll show you what that looks like. So the way the intersections work is that the wall that's running past, which is this wall, gets two studs, one on the corner, which if you're going to do a brick veneer house, it's really not necessary. But if you're going to do a timber clad or a fibre or weatherboard house, then you just need to have that stud on the corner, obviously. We then have a stud here on the end of this wall, and another stud here, which picks up the gyprock on the inside. And we end up with a little gap in here now. Depending on the size of your framing material, that could be, if you're using 90 by 45, that'll be a 45mm gap, so you can just put a piece of timber in there. Your standard bit of framing material goes in there. If this your stud and your framing material is 35mm thick, then you're going to have to cut a special piece to go in there. But you need to throw some blocking into that cluster just to hold it together, and it also gives somewhere, when we nail this wall in, somewhere to nail to. So that's a corner intersection and a corner stud cluster. We go down to an internal wall. You can see here, this plate ends here, but it's going to have one stud on the end. This plate from our internal wall, it also ends here, and it's going to have one stud on the end. This one here, the one that's running past, it's going to have one here, which will pick up this internal corner, and it's going to have a couple of blocks here for us to nail to. So that'll look like that one. So when we stand this wall up, we can nail it through into those blocks. This wall here nails into the blocks as well, and that stud there is just there to pick up that internal corner. And when it comes to a straight run, all we have is two studs together, one on the end of each wall, which when we construct the wall we can just nail straight through and tie our walls together. So we go around the entire job and we mark out our intersections. The next thing then is to mark out our windows. So if we go back to our plan, you can see here in the middle of this room I've got a window, a couple over here, one up here, all the way around there. So we'll concentrate on these two. These two are in line, so we'll concentrate on those two first. So it's actually in the middle of the room, or what I can do is I can measure my 1850 and then half of my 1710, and we can work out where the center line of the window is. And that's the center line of my window. I then need to work out how far apart my studs need to be. Now, you should have on your plan, or if you don't have it on your plan, you can get it from your window supplier, a window schedule, which looks a bit like this. This has a whole range of sizes, because this is a generic one from the manufacturer. So all you have to do is find the window that applies to the one you're looking at. And what I'll have is, in this list here, it has a reveal or stud opening size. Okay, this one's got two choices. It's either got revealed aluminium or other. So a couple of things with windows. Let's have a look at this one here. I don't know how well you'll read this on the video, but this says SW1015. So that means it's a sliding window. It means it's 1 meter high. It always gives the height first. And then 1 meter 500 or 1.5 meters wide. That's just a generic sort of standard way of expressing the size of the window. However, even though it says 1.5 wide, if you go to the top of the page here, this tells us that the frame size is actually 1 meter 570, and that the stud opening should be, for revealed aluminium, 1 meter 626. So if we had just gone with our 1.5, we'd have an opening that was too small. It also does the same thing over here for the height of the window when we come to do that. So just remember, when we're talking about window sizes, it's always expressed as a 4-digit number. The first 2 digits are the height, in this case 10, which refers to 1 meter, and the second 2 digits, in this case 15, which refers to 1.5 meters, gives us the width of the window, but they're not the actual size of our openings. You need to check with that. So in this case, our stud opening is going to be 1.626 meters. So let's go back and we can put in the stud opening, measure half of that either way, and we can position our first set of jam studs. And we have to go around and do that for all our windows. So yeah, window there, 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 and there. We've done the same thing. Positioned the jam studs at the stipulated stud opening. We also have to do the same for our doors. Well, sorry, before that, what we should do is actually mark that as our window. I'll just save on a heap of confusion. Hang on a second, I'm losing it. There we go. So we mark that that's actually a window, and I will just draw that arrow in so that we know from that stud to that stud, that's our actual window. We are going to put extra marks in there later, but so we need to know that's in the area of our window. We need to do our doors as well. So in this case, I've got a door here, which is a fairly large door, so I'm going to treat that more like a window. And then I've got doors internally as well. And we need to mark them. Just something to note, my personal preference, we already had this stud here as part of our intersection. You could use that as your door stud, your door jam stud, and just make your opening from here to here. However, what I find, especially when you're using 35mm thick studs, is that by the time you get your gyprock on this wall and then try and put a piece of architrave around your door jamb, you don't end up with a lot of room in this corner. So I prefer to stick a second stud here. It gives me just that little bit more room to play with when I come to my fix out. So I actually put a second stud on there and then put in my door width. And you can see I've done that pretty much. Yeah, got it there. Done it in everywhere that I've got a door in a corner. I've put that second stud in the corner just to get my architrave away from the corner. It just makes it a better job in the end. Personal preference, not a must. So you mark them as doors as well. And doing that for all our doors. We've got a door here. Now, in a lot of cases, because these windows and this wider door are going to have a lintel above them to carry the load around the opening, they need more than one stud that support the lintel. That's shown by the timber framing code or whoever has designed your wall frame. So in this case, these narrower windows are going to end up with 2 studs either side, and I've done the same for this wider doorway. And in some cases, the wider windows will actually need 3 studs either side. So that you just need to know how many studs you need. So one of these studs will run the full height of the wall, and these 2 studs here will actually run up underneath the lintel and support the load from the lintel. So once we've marked our windows and our doors, we then need to just fill in all the blank spaces that are bigger than our standard spacing. So in this case, I've got studs at 600 centers, or I want studs at 600 centers. The other standard spacing is 450 millimeter centers. So whichever one you're working with, we just go through and we fill in the position of those. So notice I've also gone underneath my windows as well, because we want to have jack studs underneath the windows, and it's easier to mark it out now than to mark it out later. Got it all right up along these walls. Basically anywhere that I had a blank bit of plate that was bigger than our spacing, 600 in this case, I've marked for a stud. And that's it. Our plates are all marked, or our bottom plates are all marked. Obviously the next step is to grab whatever wall you're going to build, take the plate, grab a second piece of timber the same length, which will become your top plate, and transfer the marks over onto it. And that's it. Once you've done that, you're ready to start cutting your studs and constructing the wall frame. And the sequence of constructing a wall frame is actually shown in another video, which I called wall frame components and construction sequence. So you can have a look at that one.